So rather than trying to get through all these examples in class today, I figured I'd make a video for a couple of them. So I'm in your notes on page 36, and I'm going to do parts B and C. So in class, we looked at Pete's Jeep tours and Aaron's Jeep tours. So we have these different distributions. And the first thing I want to do is I want to find and interpret the meaning. I'm doing part B, the difference D, which is defined as the random variable X minus the random variable Y. So this is, what was X earlier? The number of passengers on Pete's Jeep tours minus the number of passengers on Aaron's Jeep tours. So I want to find the difference then, is what I'm trying to say. So our rule was, if you are finding the mean of a difference, you are allowed to subtract your means. So this is the same thing. The difference is defined as X minus Y. So the rule was you can just take the mean of X and subtract the mean of Y. So we were told that the average for Pete is 3.75. The average for Aaron is 3.10. Therefore, mu sub D is 0.65. Now, that's all well and good to find it, but it would be nice if we knew what it meant. So this is saying that Pete averages 0.65 passengers more per day than Aaron does. So since I subtracted Pete minus Aaron and I got a bigger number, I'm saying that Pete must have more per day than Aaron on average. So that's how many more on average. You could also say that Aaron has 0.65 less than Pete. Those are equivalent statements. So then on part C, I'm now just flipping it. Find and interpret the mean of the difference. Now I'm doing Y minus X. So I'm going to find the difference still of Pete and Aaron, but now I'm doing Aaron's minus Pete's. So I'm just going to apply my formula. I'm wanting to find mu sub F, where F is defined as the difference of Y minus X. Then our rule that I'm applying is just I can individually subtract my averages. So it's basically the same thing. It's just the order has changed and I get a negative result. So this is just saying that Aaron averages, since I did Aaron minus Pete, Aaron averages 0.65 passengers fewer per day than Pete. Yeah, I'm just gonna have to write that. So Aaron averages 0.65 passengers So you are allowed to subtract means. Then part E is the last part I'm going to do, because now it's just not the number of passengers. We're going to also look at this application of $150 per passenger. So that means if I have 10 passengers, I have 10 150s. I would be multiplying. This is going to be one of those examples where we have a linear transformation, like the day before's lesson when we first started lesson 4. So Pete charges 150, Aaron charges 175. C is the amount of money that Pete collects, E is the amount of money that Aaron collects, and T is the total, the sum of Aaron and Pete's money. Calculate and interpret the mean of T. So I'm just going to first say I'm finding the mean of T. I'm going to write down what T is. T is the sum of these totals, and I'm allowed to add averages. But this total amount of money is found by Pete's average number of customers times the fact that he gets 150 per customer. So I'm going to say this is the mu sub C is 150 multiplied by Pete's average number of customers. Mu sub E is the average amount that Aaron collects, knowing that she gets 175 per passenger, and so I can take 175 times the average number of passengers for Aaron. And then our rule was, if you're multiplying, go ahead and multiply your average by that constant. It's not like the standard deviation where you don't add it. You do multiply. So this average gets multiplied by 150. This average gets multiplied by 175. So that's Aaron's average number of customers. And then I can find that it would be 1,105. Pete and Aaron expect to collect a total of $1,105 per day on average, again, over many randomly selected days. So I'll get that written out here so you don't have to watch me write that down, but you will be able to find it on the answer key version of the notes on our class calendar.